Hello everyone and welcome back to our channel. In a previous video we looked at three methods of solving systems of equations, otherwise called simultaneous equations. We looked at the elimination method, the substitution method, and we also looked at the graphing method. Today we want to use a different method to solve systems of equation, and that method is what we refer to as the Cramer's rule. So I find this rule particularly interesting, and that's the method I always use to solve systems of equation. It's a very straightforward and easy method to solve systems of equations. So before we start, it's important to note that any system of equation, right, can be written in the form ax is equal to b. So what do we mean by this? Let us say we have 2x plus 3y is equal to 4, and we have the second equation 3x plus 2y is equal to minus 4. We can transform this equation to, or this equation is kind of similar to a11 x1 plus a12 x2 is equal to b1, and the second equation we can represent it as a21 x1 plus a22 x2 is equal to b2. Now mind you, the subscript a11, so the subscript 11 represents the first row and the first column. Subscript 12 represents the first row but the second column. So this as well can be represented in a matrix form. So if we look at this, we can say, okay, let's just group the coefficients, right? So we're going to get a11, a12, a21, and a22, right, in matrix form. And that's our matrix A, right? And it's going to be multiplied by the variables. If we say x1 and x2, and that is going to be equal to what you have on the right hand side, which is your b1 and b2. So what do we mean? So let's represent that equation in that form now. Let's see what we get. We're going to get 2, 3, 3, 2. Now your x1 and your x2 is similar to your x and your y. So that's going to be my x and that's going to be my y, which is equal to my 4 and minus 4. So you can see I've represented this equation now in that form. And remember, this is my A, this is my X, and this is my B. So you can see this is the form I was talking about at the very start of this video. So if that is the case now, we can now use the Cramer's rule to solve this, right? It's very straightforward. Now, before I go there, if you look at the equation, this equation can be transformed back into the original equations by just multiplying this row by this column here. So if you do that, you're going to get 2x plus 3 times y. It's going to give us 3y is equal to 4. And if you do the same thing on the other side, you're going to get, again, this row multiplied by that column. You're going to get 3x plus 2y is equal to minus 4. So you can see we're getting back the original equation which we started with. Okay. Now, once you've represented these in matrix form, so again, I'll rewrite the matrix form here. So we now have 2, 3, we have 3, 2, and we multiply that by x and y is equal to 4 and minus 4. So now to solve this problem using the Cramer's rule, all we need to do is, we're looking for the first variable x. We just find the determinant of the matrix, but this time around, where you have the first column is going to be replaced by the b value. So we have a 4, a minus 4, a 3, and a 2 divided by the determinant of a. Remembering that your a is the matrix here. So that is going to be my 4 minus 4, 3, 2 divided by the determinant of a, which is 2, 3, 3, 2. Now, to understand this very well, I'll go straight on to do the y. So the y is going to be very similar, but this time around, instead of replacing this, the b value, I'll just leave it there, to the values, the original values 2, 3, but the second column is going to be replaced by the b value. So I'm going to get a 4 and a minus 4 divided by the determinant of a. That is constant for both x and y. So I'm going to get a 2, a 3, a 4, and a minus 4 divided by 2, a 3, a 3, a 2. So how do we evaluate these determinants now? The way to just remember them is that you always take the value on your top left hand corner, you multiply by the lower value. So you have a 4 times a 2. Minus is always constant if you're doing this. Into bracket now, you have a minus 4, which is the bottom left hand value, times the top right value. So you get that divided by, you do the same thing as well. So we just did that. So you do this and that one. So you get a 2 by 2 minus a 3 by 3. So if you do this correctly, you're going to be getting 8 plus 12 divided by minus 5. And if you do that correctly, you should be getting a minus 4 there. That's the value of x. Now, we do the same thing here as well. So we're going to get, again, you cross multiply these two. So you're going to get 2 times minus 4 minus a 3 times 4 divided by the determinant. Of course, we've got that before, which is minus 5. So we put it down here as this one because they're just similar. So if you do this correctly, you should be getting a minus 8 minus 12 divided by minus 5. And that should give us minus 20 divided by minus 5. And that's a 4. So that means the value of x is equal to minus 4 and the value of y is equal to a 4. So just to check, I always advise that you have to make sure that you put this back into the original equations just to make sure that the values of x and y you got are accurate. So we did that in the previous video. Just check that your left hand side is equal to the right hand side of the equations, just to check in both equations. So with that, I think you can see clearly that the Cramer's rule is very, very straightforward. I love utilizing this method because it's really easy. It's straightforward. If you just do the determinants, you get the values out of the equation. So with that, I'll stop the lecture and hope to see you in the next video. Thanks for watching. Bye.